Okay, so let's have finally a projectile type of curvilinear. A projectile is launched at point A with an initial velocity of 36.6 meters per second squared. Squared naman. Velocity. Error. At an angle of 30 degrees. With the vertical. Determine the radius of curvature of the trajectory described by the projectile at point A and at the point on the trajectory where the velocity is parallel to the incline, which is 30 degrees now. So D1, at point A is point A, letter A question. Letter B question is along the trajectory na yung orientation is parallel with the incline. Okay, so let's do this. 1.54, yes. Uy, yung delay sa delay. So let's draw for the given. This is the incline. This is 30 degrees. So this is vertical. 30 degrees of firing. So do one question, letter B. Letter A is drinay at point A. Ano ang radius of curvature? The second is parallel kuno ang. So let's draw some more view. Okay. Ito ko draw ko yung magnitude, pero nag-draw lang ko line of tangency. All right. So how do we go about this problem? First, letter A. Coordinate the radius curvature at A and the radius which is parallel at the same line. So solution is, well, of course, the radius of curvature will be that. So A is but normal solution at A is V A squared over 4A. So that's it. We need to find the normal solution and the velocity is given ang velocity 36.6. Missing na is normal acceleration. Then we can solve for normal acceleration by drawing the anong source natin ng acceleration sa projectile? Gravity. So this is our gravity. And this is the tangential. This is the normal. This is 80. This is AM. This is 30. This is also 30. And this is 60. Therefore, AM at that point A is equal to G cosine 60, right? G cosine 60. That's the normal acceleration at point A. So now. This equals to V A squared divided by this equals to 36.6 meters per second squared. The normal is G, which is 9.81 meters per second squared times cosine 60 degrees. So the radius of curvature is 273.10 meters. That's the latest curvature. At the one time, basic curvature at the namaan, a flatter on yung mga dalawa, may vicinity, yung immediate yung line is flatter. But nakong sa babaw, yun yung somewhat. May expect ka lang radius of curvature ng gamay kay grabe ka curves yung mga pa. Yung instantaneous center is lapit lang. Let's go for parallel. The normal acceleration at parallel is equals to velocity at parallel squared divided by the radius at parallel. In this case, ito wala yung missing. En parallel, velocity sa parallel, but still solvable that. If you look at this parallel one, therefore this is 30, correct? 30 parallel yan. And then, ano ganyan i-apply to concept when it comes to dealing with velocity sa projectile is that the horizontal component is the same because AX is 0. Hindi na siyang makakonect sa imo. Therefore, an initial value which is at that time or at that point, which is VO, divided 2 cosine 60 if you want, sine 30 if you want, doesn't matter. B naught times cosine 60 is still B naught cosine 60 here. Boom. So how do we solve for D? Hypotenuse. Divide mo na sa so V divide mo na sa cosine. At this time niya, ang angle is 30. Therefore, this is V naught cosine 60 divided by cosine 30. So, muna ito na hypotenuse. So, nata sa parallel. Let's go to normal. Let's draw again. G is constant. Ano ka dapat sa G? Nagalaga siya. Okay. Okay. So, may natin subungan. AN, ano ito ng G? Ano ito ng 80? So, may natin ang AN. AN kan na laban. Therefore, natin ranges of opportunity. So, what is AN this time? AN is the parallel. That is, this is 30, right? This G was in 30. Menurut lainnya, kita lihat. How we can solve it. Parallel is equals to B squared. So parallel is equals to B naught squared, which is our answer this below. B naught cosine 60/30. B naught cosine 60 cosine 30 squared divided by AN G cosine 30. Boom. So what is this? Cosine 16 divided by cosine 30 and 36.6 squared divided by 9.81 by cosine 30, 52. See, gamay siya. 52.56 meter. Okay, curves yung mga notations na ako. Hindi siya flatter. Kumbaga yung curvature. Na-reach yung curvature or curvature is reciprocal. Ang curvature is taas. Taas yung curvature, meaning drag sa curve. Dari ang mo curvature dia is nubuk, meaning mo sa flat. No, I think you did not record. I did. Yes. Nice lot. Okay, so for sample problems na. Do you have questions? Anything about the topic, about the methodology and how to solve problems using normal and tangential components for any problems related to normal and tangential components? I doubt that some problems. Could you please know what? You can also look for other sample problems. Be resourceful, no? Hindi kayo be limited. Kung ano lang lahat, taga mo lang ako na hindi dapat be resourceful. Be first habit of 7 habits of highly effective people. Always take initiative. You know what? If there are books that I want to suggest you should start reading, some of the semester book is 7 habits of highly effective people, and the other one is how to take smart notes based on Ken Aren, something like that. Ano pa mga year, second year, mas early, mas better. Especially sa knowledge management system, kung paano mag-manage siya. Okay, so I digress. I hope na-deliver ko ang key concepts regarding normal and tangential components. And I hope na nakatag natin sa problems to cover the key concepts. And that's basically it. If you have questions, please don't hesitate to message me. And next time, before we meet again for another lecture, we'll have a quiz for this topic. And after that, we'll go on to the next topic. Supposed to be that's the pattern. Before we go to the next lecture, we'll have a quiz and quiz lecture. Very yeah. I hope we'll get back on track. Okay, so I thank for all those that have attended, and I really hope for your nice feedback. Okay, so thank you everyone. Goodbye.